Tell them what you got for the next 5 elements and explain what you did. 30 seconds. Go ahead.
6, 7, 8, 5, 7, 10. What did you get? 6, 7, 8, 10. What the heck? I got way off.
21,
15 seconds. Alright.
I don't get this.
Alright, let me get your attention. Back over here, guys and girls. Back over here. Put that away, please. Please, please, please. Put that away.
Stranger Things poster where everything's strange.
Cool? Great. Okay, so here's the deal. If you're super comfortable with that pattern that you found, I'd like you to put thumbs up. Hey, wait, in 3 seconds, I'm gonna. Yeah, you don't even know what thumbs down, thumbs to the side mean. Thumbs down means clueless on the pattern, and even after hearing somebody else's explanation, you're like, I still don't get it. Thumb to the side. You heard the other person's explanation, and you're like, you know what? I either understand their explanation, I don't understand the sequence, or I understand the sequence, that's cool, but I don't understand their explanation. So you're still unsure about something. So, on the count of 3, thumbs up, we're good, not so good, and this one, but I'll go ahead and go with their answer. Ready? 1, 2, 3. Let's see, good, bad, sideways.
I'm good. G-O-O-P.
Alright. Let me go right now with a thumbs down. So that would be, let's see, what did you have who had thumbs down?
Nope.
Did you have thumbs down? Jaden? Alright, so Jaden. Tell me your sequence. Tell me your sequence and tell me why you feel uncomfortable about it. Go ahead. Six, 7, 8, 9, and 9. Now that's what she feels, and she doesn't feel comfortable with it. So I'm like, all right, who had thumbs this side? Let's see it. John, Juan, did you have thumbs this side? Why did you have thumbs this side? Or tell me.
I understand the sequence, but I didn't get the explanation.
Oh, you did the other explanation. Okay. So what was his sequence?
1, 1, 2, 3, 5, 6, 6, 7, 8.
Okay. So you didn't get the explanation, but you see the pattern. Okay, great. Now, who had thumbs up? All right. You had thumbs up, sir. Can you explain to Sergio? Give him the answer to this, and then explain how you got it. Go ahead.
So the first one or the one?
Just the first one.
6.
He says 6, and why?
Because,
Well, you're explaining it to Sergio.
oh, it's because after 5.
That's smart, bro.
That's 5 and 6. Okay. So see, that's what some people's explanation would be. All right, Sergio, you had thumbs up. All right, I want you to explain to Tadeo your next number and how you got it.
I got 12 because. Oh no, I got 8.
You got 8 because
3 plus 5 is 8.
3 plus 5 is 8. Okay. Tadeo, agree or disagree?
I agree.
You agree? Okay. Now here's the deal, Tadeo. I would like for you to explain to John. Okay. By the way, I'll write that down just because I had somebody who agreed. Real quick, he said 3 plus 5 is 8. Tadeo said, yeah, sure, no problem. Tadeo, explain how you get the next one to John.
Well, the next one I got 13 because I added 5 and 8.
And you got
Yes.
13.
All right, cool.
Yes.
John, do you agree with what's going on here? Kinda? Okay, so here's the deal. John, I'd like for you to explain to Samantha the next number. Thank you. And why? Some people say it's 21, so he says that's 21. Okay? You may or may not agree with it, but I'm saying, okay? Now, Samantha, can Can you explain to Alize what the next number might be? No?
I can't. I'm beautiful at doing this kind of things.
Not sure?
Man.
Alright, Alize, can you explain to Susanna what the next number might be? Say it again? And why? Okay, and now Susanna, I would like for you to explain to anybody you want to the next
Right here, right here. This girl. This girl.
And? Okay, so ladies and gentlemen, here's the deal. There were several different reasons why people, and I get it. Some of y'all are like, okay, I'll agree with this number because, but the reason didn't make any sense. And Juan was the first one to admit, he goes, well, I see why I got it, but it didn't make sense to me why I did it. And then we had somebody who's like, gets the next number and says, okay, I totally agree with that. And then it's like, okay, I can even repeat it. And I could actually duplicate that. And then you all just started learning from each other. Now here's the deal. This sequence of numbers actually has a very special name. This name is...
No. Such a weird name. But honestly,
This is called the Fibonacci sequence. Now, ladies and gentlemen, the Fibonacci sequence is found in art. It's found in nature. It's found in music. It's found in tons of stuff. And we're going to actually see some of the things that you'll find out, and you'll see where you see it in nature. But here's the deal. With Fibonacci sequence, not only can we generate the sequence, but we can start generating other kinds of patterns with it. And I'm going to show you those other kinds of patterns we can generate with it. Okay? Alright, so what I'd like you to do before we do that, because there's something kind of special about this. What I'm going to do is I'm going to eliminate these first two numbers right now, and I'm just going to look at these numbers here. And what I'm going to do, I'm going to ask you to take two numbers that are side by side or adjacent, okay? Two numbers that are side by side and divide them. You're going to divide the smaller number by the bigger number. Okay, I'm going to give you 2 minutes to divide the smaller number by the bigger number, and here's the deal. I'm going to tell you, I'm going to divide these two. My smaller number is 34. My bigger number is 55. And they're next to each other. So as long as you pick two numbers that are next to each other and divide them, the small one by the big one, you're doing what I'm asking you to do. Give you 2 minutes. Go ahead and divide. Any two you want to. If you want to do the one I'm doing, you can. Good job. That was a good explanation. You never returned my copy. You never returned it.
I never borrowed your pencil.
I'm not that smart.
45 more seconds.
I'm not ready for college. I'm not ready.
Divide.
What else?
20 more seconds. Alright, ladies and gentlemen, here we go. So, just going to model some division because, again, I told you at the very beginning, division was the thing I was a little worried about, and then our social studies teachers helped us out. Y'all got a little bit better at it, and then it's actually some pretty good practice. So check this out. 55 does not go into 34, however, it does go into 340. It goes into 340 6 times. 6 times 55 is 330, and I'm going to subtract this. This is going to give me 10. I'm going to bring down the 0. 55 goes into 100 only once. Because when I do that, it's going to be 55. That's going to give me 45. Ladies and gentlemen, when I drop down the 0, it's going to be 450. It almost goes into it 9 times, but it only goes into it 8 times. That's going to give me 440, and then I'm going to have remainder 10. And I'm like, okay, well, you know what? Here's the deal. If you got 3 decimal places, I'm super happy about it. Check it out. My answer for my division problem is 0.618. Now, John, what did you divide? You divided 5 and 8. What did you get when you divided 5 by 8? Very good. You got 6.25. Now, that's not exactly the same as mine, but it's relatively close. Jeremiah, what did you divide?
3 by 2.
You divided 3 by 2. What did you get?
0.666.
0.66. Well, I'll put 7 because I'm afraid of 6. Here we go. You know, he didn't get what I got, and he didn't get what John got, but it's still 0.667, 6.61, 6.625. Who did a different division? What did you divide? What did you get?
I got 0.6110.
610?
Yeah.
Very good. Here's the deal. Not the same as mine, not the same as anybody's, but do y'all see some kind of similarity?
Yes.
Google, don't say it. Tadeo, did you divide anything else? Did anybody divide 21 by 34? Anybody? No?
I can do that right now.
Oh no, here's the deal. It's good that you did it, because check this out, I already did. It's actually 0.615. So, yo, check this out.
No, so that's 6.115.
This thing, if we keep going on the Fibonacci pattern, by the way, is 55 the last Fibonacci number?
No.
We could just keep adding them together and get up the next one. Well, here's the deal. If you keep adding these numbers together, ladies and gentlemen, the Fibonacci number is going to start approaching a number. Well, for all practical purposes, ladies and gentlemen, this is the number it's going to approach.
0.
This number we call phi. Now, earlier in the year, y'all learned about pi. Earlier in the year, you learned about pi. Now, I'm going to teach you about phi. Now, phi is another Greek letter. Phi is actually equivalent to F. Okay? Physical ed, physics, all have something to do with the phi. Now, check this out. The phi, right here, this 0.618, is actually the golden ratio. They called it the golden ratio. And some people are like, why do they call it golden ratio? Liz, when they call something golden, what do you think about it?
Special.
It's special.
And it's valuable.
It's valuable. Check this out. Skyla, when I call something golden, say, oh, this is golden, what would you think about it? It's valuable. Yeah, I know. That's another. Jaden, it's perfect. Check this out. When something's golden, it's like perfect. Check this out. I like that. The golden ratio is kind of perfect in a sense that it's mathematically perfect. For instance, this sheet of paper here. If I were to give you an assignment on this sheet of paper, it probably wouldn't be a problem if I gave you the assignment like this or like this, right? As a matter of fact, I give you your do nows. Your do nows have this shape, right? Now, what would you do if you walked in one day and your do nows had this shape?
No way.
Like, is this do now?
Yeah.
That was a rectangle.
Let's do now.
But here's the deal. This has a funny shape, and our brains, they'll accept it. If there's problems on there, you can do it. But our brains look at this shape and go,
Do now.
it just seems weird. But check this out. this right here has the exact same area as this. Only this is better for our brains to accept and go like, hey, that's kind of like what he says, it's perfect.